Okay, so today I'm going to tell you another kind of data set that consists of 200 product sales along with advertising budgets for three different media, TV, radio, and newspaper. So that kind of data is a little bit different because it's stored in the CSV file. It's not a DTA file, so we have another kind of command to import and load the data. Before doing that, of course, we need to make the working directory. But as usual, like I showed you before, try to work in the directory like where the data is stored. And then we have to load the data because it's not in the DTA file format. And we have another kind of a way. We're not using the use command here. We will use import daily using, and that is a kind of file we are using advertising. You can type or you can copy paste, it doesn't matter. And also you clear. So we are already load the file, and like I said, always try to read the data first before doing something else. So we can use the browse to see what kind of data here. This one is just like the number of observations, so it doesn't carry the v1 or something. It's just like the list of the number. And we have the four variable here: the TV, radio, newspaper, and sales. And sales is measured in thousands of dollars. The TV, it means the TV budget also measured in thousands of dollars. The same with radio, newspaper, $1,000. So otherwise you see the number here is a little bit small, but when you try to interpret the data result later, you have to multiply it with 1,000 to have the correct interpretations. And we have the TV budget, radio budget, newspaper budget, even that we don't see the label here. But because it's quite easy and quite obvious to see from the names of the variables, so I'll let you try to understand what it's about. And now the problem here, you are interested in how the advertising budget is related to the sale. So it means like the sale will be your dependent variable, and we have the three independent variable: TV, radio, and newspaper budgets. So that we have some informations. The same, we can use a summary or summarize command. Try to see the list of the variables, the observations. So we see that it 100. No missing variable here. And we have the mean, the average value, the standard deviations, the minimum, and the maximum value. So it's quite easy because we don't have much variable here. So it's straightforward to understand the data. And now we are going to that the way we make yourself familiar with the data, and now we try to plot each of the variable TV, radio, and newspaper against the dependent variable sales. So when I make many kind of plot the data, but in this example we try to see the relationship between the sale and each of the media buses. And normally people will use a scatter. It means a kind of plot that I will show you the image later, but the general command is a scatter, and we input the y dependent variable and then the x variable, and then you see that we see a lot here. Each dot mean each observations. We have the 100, 200 observation here. And slightly we can say that if we fit the regression line here, so it's kind of positive here, right? So that's the reason why we have this kind of plot, that you can see clearly the relationship between the TV and the cell. Similarly, we can do the same with its type of buses. So the next one, the radio, right? Okay, sorry, that typo here, scatter video. Now we also see the same kind of relationship. We repeat the regression line here, but you can see the observation a little bit spread and scatter from the regression line here. The same with sale and the newspaper. It's a little bit different from two previous scatter plot, because we kind of see a little bit of the positive relationship, but you see the all kind of observation, it's just around this area, so it's just around this place. It seems like very weak relationship between the newspaper and sales. So now we try to analyze the regression result. We have to feed a simple linear regression for each of the explanatory variable. Explanatory variable is mean also independent variable is x, using the common regressions y and x. So we try to see the actual number result at the C. Here is the cell TV coefficient here, standard deviation, the t and the p-value, and significant level 500, so that they automatically made by the STATA. So when you try to say it, we have to look at the t-value, have to like absolute value. Actually, it doesn't matter. It's we use absolute value. We have to see that if more than the 1.96 or to add the rule of thumb, because it's almost 2 anyway, and the b-value less than 0.05, like 500 significant level, 5%, sorry. So when we look at this kind of result, we can see that it's the same with TV and cell here. We see that it satisfies the condition here. So it means like it's significant, statistically significant, right? So based on this, the kind of rule of times, we already look at the result of the regression to see that if each kind of the media buzzes can affect the cell in which way and if they are significant or not. So we can do the same regression between the cell and the radio. And we also see that is a positive relationship, and the t and b value also satisfy what I have said before, so they are significant. Do the same with the newspaper. We also that is kind of significant as well at the 500 significant level, 5% significant level. So how do we interpret this kind of thing? For example, remember that I said before, the numbers here we have to multiply with 1,000 because it matters in $1,000, right? So when we interpret this kind of result, for example, between the cell and TV, so we have the an increase in the TV budget by $1,000 is associated with an increase in sales by this number multiplied with $1,000. So it's around 47.54 dollar on average, and this is statistically significant at 5% significant level, because I said the t value and the b value satisfy what the condition I said before. The same with the radio. An increase in the radio budget by 1,000 is associated with an increase in sales by this number, also the same, multiply with 1,000, so it's 202 and 50 cents, 0.50, so it's 50 cents on average. This is statistically significant at 5% significant level. Sorry, I always say it's hundreds, but it's 5% significant level. And also the same with sale and newspaper, an increase in the newspaper purchase by 1,000 is associated with an increase in sales by 54. We multiply with 1,000 here, so it's $54 and 69 cents on average. This is statistically significant at 5% significant level because we also the D and the p value satisfy the conditions. And now this is another way you have, like I said from the plot before, we need to fit the regression line. So this is a way how you do it. You use a command two-way. First, you have to scatter the plot the cast box, and then we use a L fit. So we fit the regression line, linear regression between the cells and the TV, and see. You see the fit value in the red line here. So you clearly see that, okay, that is a positive relationships and quite nice here between the TV and the cell. You can do the same with the radio and newspaper to see actually visualize what you are looking for. So the kind of positive line, as such, this kind of observation is quite spread around the line further on the regression line. And say we can use a newspaper. You see a little bit of the positive here, but actually it's not really necessarily the case because later we can see that we don't really think that there is any effect between the newspaper and the sale when we do the multilinear regressions. So we have just done something very separately. We try to see the relation between each independent variable. I mean, it's kind of media budgets affect to the sales. But we are not satisfied with the result because we have something a little bit different between the newspaper and sales. So that reason why we going to the next step. We try to regress all of the independent variable in one regressions, so that we call the multiple linear regressions. So we do the same, but instead only have TV, we put the radio and the newspaper here. We see the whole picture of regressions and the effect between the TV, radio, newspaper, buzzed into the cell all together. And as you see, the coefficient of TV and radio reduce a little bit. Here is 0.045, and here we see 7, right? 0.047, and for radio it's 0.202, and it becomes 0.188. So the coefficient of TV and radio reduced a little bit in the multiple linear compared to the simple linear that we have to solve. And they are still statistically significant in both. Like we simply the T and the B value satisfy the condition, so they're still statistically significant at 5% significant level. However, the coefficient of the newspaper reduced a lot more. It's become from here. It's very small, but from here it's become negative and very small, only minus 0.001. it become the negative and the multiple linear, but it also no longer statistically significant because you see the t value, the b value, they are not satisfy the condition we have set before. The simple linear regression show the correlation between the cell and each of the various media. It answers the questions how much will cell change on average if the TV budget increased by 1,000, like we have to try to interpret before. It's the same like how much will cell change on average if the radio or newspaper budget is increased by $1,000. But in the multiple linear regression show how one media is associated with the cell while taking into account the other media. It answers the questions how much will cell change if the TV budget is increased by $1,000 while holding the radio and newspaper budgets constant. So for example, when we try to interpret the kind of data, the kind of result, for this, the multiple linear regressions, we can say like an increase in the TV budget by 1,000 is associated with an increase in sales by this number multiply 1,000. So it's $45.76 on average. Ceteris paribus. Ceteris paribus. It's just like the Greek name, or you can just say the same meaning like while holding the other variable, or you can say the exact name like the radio newspaper, like in this specific example, constant. So it's just like set up with parity, but it's a short way to say while you holding the other variable constant. The same with radio. When we say an increase in the radio budget by 1,000 is associated with an increase in sale by multiply this 1,000, remember, and it's $188.53 on average while holding the TV or newspaper budget constant or ceteris paribus. That is statistically significant at 5% significant level because you see the TV value and the p value. Newspaper, an increase in the newspaper budget by $1,000 is associated with a decrease in sales by decrease. Before that we say increase because it's a positive relationship, but now we see the minus, so it means a decrease in sale by 1. We multiply this with 1,000, so it's $1.04 on average. So this is not statistically significant at the 5% significant level because you see the t value and p value doesn't don't satisfy the requirement, so it's not statistically significant anymore. So we see that from our result, we can see the TV and radio are correlated to cell. TV and radio are correlated to cell. When we account for all the media, they still have some significant association with cells. However, for newspaper, the story is different. We see a significant correlation between cell and newspaper separately, but when we account for the other two media, we see the coefficient is almost zero. Like you see, very small. But when we account for the other two cells, and it's become insignificant. So we find that maybe have to further explanation here. First of all, we have to look at the correlation metric. The correlation metric to help you to see the correlation among the variable, including the independent and dependent variable. So instead we can use a command CORA, which means correlation between the cell, TV, radio, newspaper, and the value always range from 0 to 1. So it means like equal to 1. It means like they're very high and they are correlated to each other. but more normally we will take like more than 0.5. Mean that there are correlation between the two variables. So for example, here we see the TV radio is very high here, so they are correlated to the cell. And between radio TV is small, like it's less than 0.1, so it's are not related to each other. The same between newspaper and TV. We also see a little bit of correlation between newspaper and cell, but for example, here from radio and the newspaper, we see a kind of higher the correlations among the two, even that is not linked to 0.5, but I'd say it really depends on the purpose of analysis and interpretations. And before that, we see there's something happened with the newspaper affect to the cell. So we see here the Z number can indicate something like there correlation between the newspaper and TV. So which mean if they are correlated to each other, it means that they probably use simultaneously at the same time. When a radio effort is made, there is also a newspaper effort. This means the result from the multiple linear are showing that the radio advertisement is bringing in the sales, not the newspaper. So it means like the radio here will bring the sale and not the newspaper. So, but it means like they are called get together to bring to sale. So that's the reason why radio should be put in here. And further later, we can say that newspaper should not put into multi-linear regression because it doesn't explain more about the sales. Okay, so that is the end of the tutorial today that we try to input the different file or data file in the STATA. We try to do some simple linear regressions, multilinear regressions, and try to interpret the result in each case to get more deeper understanding of the data sets. And we will do another kind of the same data set about this information, and hope to see you next time.